Hello everybody, my name is Denis Kotkov, I'm a postdoctoral researcher at the University of Helsinki, and now I would like to present to you our study on movie tag rating inconsistency. I would like to start with this website. It is called Movie Lens, and it provides recommendations of movies to users based on movies these users rated in the past. For example, this movie is called Forrest Gump, and I like this movie, I gave it 5 stars out of 5. What this website also allows to do is that it allows to attach tags to movies. And I remember that there was a lot of running in this movie. That is why I can attach this tag to this movie. I can also see that 18 other users also attached this tag to this movie. And this is a very common functionality for many websites. For example, Instagram allows to attach hashtags to pictures, or Twitter allows to attach hashtags to messages. So far I have only been talking about unary ratings, when we only know when the tag applies to an item. We don't even know when the tag does not apply to an item. However, these ratings can also be continuous relevant scores. For example, tag genome contains scores that indicate the degree to which a tag applies to a movie. For example, Back to the Future is about time travel. That is why this tag applies to this movie with a score of 1 on the scale from 0 to 1. This movie also has some drama. That is why the tag drama applies to this movie with a score of 0.5 on the scale from 0 to 1. We can generate the scores based on item content. For example, we can analyze the movie itself, or we can analyze reviews of the movie. However, we can also retrieve these ratings from annotators. And when I say an annotator, I mean a user who enters the ratings voluntarily, or an individual who is paid to do this. And our first research question was, when we retrieve this data from annotators, how inconsistent this data is. If we ask an annotator the following question, to what degree does the tag adventure apply to the movie The Matrix, on the scale from 1 does not apply, to 5 applies very strongly. Some annotators would say that it is 4 out of 5, some would say it's 3 out of 5, some would say it's 5 out of 5, and some would even say it's 2 out of 5. So we wanted to find out how inconsistent these ratings are and what factors are associated with this inconsistency. Our second research question was inspired by the hypothesis that subjective tags are more inconsistent than objective ones, because subjective tags include annotator opinions while objective ones don't. For example, an annotator might think that a movie has a bad plot, but another annotator might disagree with them. However, if the movie is animated, then probably most annotators will agree that the movie is animated. To answer our research questions, we first conducted semi-structured interviews, where we asked participants to fill in our survey, where they needed to indicate the degree to which tags apply to various movies and books. We then asked participants to discuss their answers between each other, and where they had different ratings, they had to agree on a common rating, or they could also agree to disagree. We listened to their conversations to find out reasons why participants disagree on their ratings. We used these reasons to design our survey, which consisted of 4 parts. In the first part, we asked an annotator to pick first 10 movies that they watched from a list of movies that were ordered randomly. We randomized the order of movies to ensure that all movies had an equal chance of being rated. Second, we asked annotators how long ago they watched movies that they have selected, because from our semi-structured interviews we found out that participants sometimes just misremember movies. And I'm going to refer to this question as time gap. Then we asked annotators to indicate the degree to which a tag applies to a movie, and I'm going to refer to this question as rating. We also provided high and low scoring examples for every rating question, because we found out that these examples help annotators to provide more precise ratings. We also asked annotators how easy it was for them to provide the rating, and I'm going to refer to this question as the ease of rating. We added this question because some movie tag pairs are just difficult to rate, according to our participants in the semi-structured interviews. And finally, we asked annotators how familiar they were with tags, because we found out that participants sometimes have different understanding of tags, and I'm going to refer to this question as familiarity. We also asked annotators how often they watch movies that can be described with a tag, and I'm going to refer to this question as frequency. We added this question because participants sometimes have different rating scales depending on their past experience. For example, if one user has watched plenty of horror movies, when we ask them to what degree does the tag horror applies to a particular movie, they might give pretty low rating just because they have seen so many horror movies in the past. For our survey, we picked the most popular tags from movie lens and categorized them in the following categories. They were objective, such as aliens, animation, Christmas; subjective, such as artistic, atmospheric, bittersweet; genre, such as action, adventure, art house; and miscellaneous, such as culture clash, cyberpunk, and dystopia. Approximately, we picked 20 tags per category. For each tag, we picked movies that have high, medium, and low relevance for the tag based on the tag genome dataset, which I talked about in the beginning. Overall, we picked around 140 movies. This is the example for the tag called space. Apollo 13 is about space. That is why this tag has high relevance for this movie. Toy Story is not about space, but there is a character whose name is Buzz Lightyear, and according to the story, he traveled in space. That is why this tag has medium relevance to this movie. And finally, there is the movie Forrest Gump, which doesn't even mention space. That is why this tag has low relevance for this movie. We ran our survey in Amazon Mechanical Turk and received around 4,000 ratings from 450 annotators. Most movie tag pairs received 5 ratings, and that was our goal. Most of our ratings were indicated that a tag applied to the movie very strongly or just strongly. However, there was also a peak when the tag does not apply to the movie at all. The key concept of this paper is rating consistency. We consider a rating to be consistent if it is consistent with the mode rating for a given movie tag pair, and around half of our ratings were consistent. Next, we wanted to find out the difference in inconsistency between different tag categories, and to answer this question, we ran multiple pairwise comparisons. We also adjusted our p-values with Bonferroni correction to avoid false discoveries. We ran 6 mixed effect logistic regression models where our dependent variable was the binary variable indicating whether the rating was consistent with the mode rating for a given movie tag pair, and our independent variable indicated the category, and we also had the random effect of annotator ID, which we included because we wanted to take into account repeated measures for annotators. Each logistic regression was run on a separate dataset. For example, this one only consisted of objective and subjective tags, where objective tags were coded as 1 and subjective ones were coded as 0. These results suggest that subjective tags are more inconsistent than objective ones. In particular, the odds of a rating being consistent for an objective tag were 36% higher on average than for a subjective tag. So this hypothesis that I talked about in the beginning, it was confirmed. And now we wanted to find out what this difference in inconsistency might be associated with. And to answer this question, we ran 4 cumulative link mixed effect ordinal regression models only for objective and subjective tags, where our dependent variable was annotator answered to our survey questions, and our independent variable was the category, which was 1 for objective tags and 0 for subjective ones. We found out that annotators find objective tags more familiar than subjective ones, and they also find objective tags easier to rate than subjective ones. And when we looked at the set of tags that we selected for objective and subjective tags, it really looked like that, because objective tags seem to be just simpler. Objective tags include tags such as robots, space, superhero, time travel, pirates, animation, while subjective ones include quirky, stylized, surreal, tense, original, atmospheric. And that could be related to two reasons. Users might choose more complicated words for subjective tags, or subjective feelings might be just harder to express. That is why users need to use more complicated words for that. Finally, we wanted to find out what rating inconsistency is associated with. And to answer this question, we ran a mixed effect logistic regression model on the whole dataset, where our dependent variable was the binary variable indicating whether the rating was consistent with the mode rating for a given movie tag pair, and our independent variable included annotator answers to our survey questions and the category of the tag. We found out that the only one and the strongest predictor of whether the annotator is going to provide a consistent rating to a movie tag pair is how easy the annotator finds it to provide the rating. In particular, we see a 59% increase in the odds of consistent rating for a 1 unit increase in the ease of rating. Our results imply that subjective item tag ratings are more inconsistent than objective ones, but not due to different annotator opinions. It is because annotators are less familiar with subjective tags and find them more difficult to rate. Annotators are aware of the quality of their own ratings. They are more inconsistent with item tag pairs that they find difficult to rate. Finally, this study has a number of limitations. A different sample of tags might produce a different result. Our findings might only apply to popular movies and tags because these are the movies and tags we selected for our survey. And finally, we selected factors based on semi-structured interviews, but there also might be other reasons that we did not take into account. Finally, I would like to invite you to our GitHub repository where we share the code and the dataset used in this study, and I would also like to thank organizations that supported this research, the Academy of Finland and the Finnish Center for Artificial Intelligence. Thank you for your attention, and I will be happy to answer your questions.